If you could tell me a little bit about the hypothesis that you and your colleagues had.
We know that language is a really powerful tool for learning. Language helps kids learn how to communicate with others, but really language helps us learn even more language and things in the world. And research has shown that children's spatial language is particularly important for supporting their spatial skills. And right now there's a lot of research being studied on how we can improve spatial skills, because we know that spatial skills early in development are linked to math and science achievement, but also the desire to be in a science, technology, engineering, or mathematics field. So we really want to know, how can we use language to improve children's spatial skills?
Could you describe for me, when you're talking about spatial language, but what kinds of words and what kinds of terms are you talking about?
Early in development, spatial words consist of words like middle, left, right, any sort of words that orient a child in space.
You were looking at children and when they start understanding these words or using these words in context. If you could give me a few more details about what you were looking at.
What we were really interested in was the words that children produce on their own when they're doing these spatial tasks such as puzzles or blocks. And not only did we want to know which words do children use, like do they say left, do they say right, do they say top, do they say bottom, but we wanted to know if they could flexibly use these words. That is, if I give children a whole bunch of different spatial tasks, do they change the words that they use depending on the task that they're given?
How did you go about studying this?
Well, I have been interested in children's language for a long time, because language is a very powerful tool for children to learn early in development. And I got to work with an incredible graduate student. Her name is Hillary Miller. She already graduated this May, and she is now at Emory University doing a postdoc. And a colleague here at the University of Wisconsin, Vanessa Simmering, who the three of us all sort of got together and just had this idea, and we were surprised that no one had tested whether children can adapt their language across different spatial tasks. So not only were we inspired because this is something that is really important to STEM education, to science and math interest, but also just a question of how children use language. So both theoretically and for applied reasons, we thought this work was really important.
Tell me some of the particulars of the study. How many kids you studied over what period of time?
We invite children to come to campus to participate in studies with their parents. And they come to our laboratory, and our laboratory is set up such that we've got cameras and recording equipment to figure out what children are doing while they do these tasks. But in this case, we're really interested in what kids say, such as those spatial words. So once parents and children arrive to campus, they start participating in the study by having the child do a series of tasks. And those tasks include spatial tasks, where children will see 3 blocks oriented at the top, middle, and bottom of the screen, and there'll be a cute little mouse on one of those boxes. And it's the child's job to describe to the experimenter, or Bucky the Badger, which is a stuffed animal we put on the screen, and we say, can you tell Bucky where the mouse is? And Bucky can't see the screen, so the child has to use language and language only to tell Bucky where that mouse is.
So if you could tell me how you and your colleagues conducted the study.
We worked with over 40 children that were about 4 years old, and the reason that we selected that age group is because this is a really unique age for learning spatial words. Children don't quite know left or right yet, but they do know words like top, bottom, and middle. So what we did is we invited parents and children to come to campus to participate in the study in our laboratory. And the laboratory is set up such that we can record what children do during various spatial, language, etc. tasks. And in this experiment, we gave children a series of those tasks. So we presented children with a spatial task where they saw 3 blocks on the screen, one on the top, one in the middle, and one on the bottom. And on top of one of those boxes was a little mouse. And what the child had to do was describe where on the screen the mouse was to Bucky the badger, a stuffed animal that was sitting on the table. And Bucky can't see the screen, so it's the child's job to use language to describe where the mouse is. So children will say things like, Bucky, the little mouse is on top of the red box. And we assess what children say, but also how good that language is for being informative to Bucky. So could Bucky really figure out where the mouse was?
Once you have the lab work, then how do you analyze? What do you do from there?
What we do after we give children a series of spatial and language tasks is we have undergraduate students who are research assistants in the lab code the videos. And what that means is they watch the videos and they write down what types of words the children say, how often they say those words, and we do that with multiple coders so that there's agreement, so that everybody agrees on what the child said during the experiment. And after we've coded all that information from the videos, we then do statistical analyses on the data to figure out what types of words kids said during the experiment to a greater degree than other types of words.
What did you determine?
What we found is that children at this age do produce spatial language, and that predicts their spatial skills. And that confirms previous research. We already knew that knowing spatial words helps children with their spatial skills. However, what was unique about our study is we gave children a whole bunch of different spatial tasks and we tried to observe how that varied across the different types of spatial tasks. So we basically had an adaptation score where it was a measure of how good children are at adapting the types of spatial words they use. So what we found was that children who are not only producing more spatial words, but also being more adaptive in using those spatial words were the ones that had the strongest spatial skills.
If you could explain, why is that important, that they are able to adapt and they have those words?
Being adaptive in your use of language, especially spatial language, is extremely important. And the reason is that our spatial view of the world is constantly changing when we move our bodies, when we're trying to explain something to someone else who has a different perspective of the world. And we have to consider the context in which we use our spatial language. For instance, my left is not your left, and my right is not your right. It switches when I'm looking at someone. And so to really understand how to orient ourselves in the world and communicate with others, we do need to be extremely adaptive in the way that we use spatial language. So it's a very important skill for kids to acquire.
What are the implications?
There are many implications. So one is that parents should be using spatial language with children when they're engaging in block play, puzzles, any sort of spatial activity. This way, children are associating language with the spatial cues that they get from the environment. So when they've got a piece of puzzle that they need to put in the puzzle, they're really orienting the piece to put it in appropriately. What parents should be doing is saying, oh, this looks more like a triangle piece than a square piece. So that way, parents are teaching children to learn to associate spatial words with spatial skills.
Were there some other implications?
Yes.
Were there some other takeaways?
Lots of good takeaways. So the next one is that using spatial language is really important for parents to do when they're playing with their children, but also to adapt their own language when they're playing with children. So parents are often tempted to say the same word over and over again, like this piece goes in the middle, this piece goes in the middle. Well, instead, what parents should be doing is varying their language so that in one context they say this is in the middle, but perhaps in another context say this is in the center, okay? Which are similar words but have different meaning across different contexts. And when parents are adaptive in their language use, their children will be more likely to be adaptive in their own language acquisition.
Any other takeaways?
The third is that, and this is more broad in scope, is really spatial language is a way to train children to have better spatial skills. And we know that children acquiring good spatial skills in the first few years of life is critical because it's one of the strongest predictors of academic success in math and science, and later on, years later, when children become college students, entry into science, technology, engineering, and mathematics careers.
So it all could start with what you're doing with your child on the living room floor with blocks.
Yes, it seems odd that, just playing with puzzles and talking to your kids at 4 years of age could predict what they're doing in college and what their major is. But the data suggests that these early activities, and especially these early language experiences, are critical for those outcomes long term.
Is there anything I didn't ask you, Haley, that you would want our viewers to know?
A lot of these principles don't just apply to spatial language. There is language in many different domains, and talking to your children and providing them a variety of language experiences early on is extremely important. And the reason is, for what I was saying earlier, that language is a powerful tool. It helps us communicate, but it also helps us learn more. And so the more exposure that parents give their children to a variety of different languages, the more, or language I should say, the more likely they are to have an ability to learn more across domains.
Your expertise is in
how children think and learn, so children's cognitive development.
a little bit about your background. If you could tell me where you got your undergraduate degree, master's, and advanced degree.
I started my academic career at Carnegie Mellon, and I was there for 4 years, and I majored in psychology. And from there, I went to the University of California, Los Angeles, UCLA, and I was there for 6 years getting my PhD and master's. And from there, I moved directly to here, the University of Wisconsin.